Hi, today we will learn how to detect a cycle in a directed graph as well as in an undirected graph using depth first search, and we will also look at the subtle difference between the approaches for these two kinds of graphs. We say that a directed graph has a cycle. When I start exploring from a particular node and I'm exploring it in a depth first manner, and somehow I reach back to the node from where I had started, if so happens, then the given directed graph has a cycle. Suppose this is the graph given to us. We are given its adjacency list and I am maintaining a visited array in order to keep track of the nodes that have been explored already. And here is this, I'm also maintaining the track of the nodes that are in the call stack. What does it mean to be in the call stack? Suppose when I start exploring from node 1 here, so I will put 1 in the call stack because I've started from 1 and 1 is not yet completely explored. From 1 I move on to 2. So I put 2 in my call stack. From 2 I move on to 3. So I put 3 in my call stack. From 3 I have nowhere to go. So I will trace back to the node from where it was called and pop it off from the stack. So this is what the call stack is. Now I can start exploring this graph in any way possible. Suppose I start with the node 0. From 0, there is only one way to go and that is node 1. So from 0, first of all, when I'm starting from 0, I have to mark 0 as visited and I have to put 0 in my call stack. From 0, there is only one option to go and that is to node 1. So from 0, I'm going to node 1. So now 1 is to be marked as visited and it is to be put in the call stack. From 1, there is nowhere to go. So I will pop it off from my call stack and go back to 0. From 0, again there is nothing to explore. So pop it off. And now I can start exploring again from any of the nodes that have not been yet visited, that is 2, 3 or 4. Suppose we start with 3 now. Now I'm starting from 3, so I have to mark 3 as visited and I have to put it in my call stack. From 3, there is only one way to go and that is 4. So I go to 4, I mark 4 as visited and I put it in the call stack. From 4, I can go to 0, but 0 has been already visited, so no need to explore it again because we have already explored it. The other way to go from 4 is to go towards 2. So now I'll go towards 2. So 2 is to be marked as visited and 2 will be put in the call stack. From 2, there are two ways to go. One is to 1, but 1 has been already visited, so we can't go there. We have already explored that option. So from 2, we can go now to 3. Now 3 is also visited. So it means we don't have to explore 3. But what is different about 3? 3 is already in the call stack. So this means that we have reached 2 while exploring the children, while going in a depth first manner from 3, and from 2 I am reaching 3 again. So this indicates the presence of a cycle. So when do we say we have a cycle? If while exploring I reach back the node from where I had started. And how do I know that I have been exploring from here? Because it was put in the call stack. And while exploring in the depth first manner, I am reaching 3 again. So this gives the presence of a cycle. Now let's have a look at the pseudocode for finding a cycle in the directed graph. I will be posting the link of the whole code in the description. So suppose we have S is the node from where we have started exploring. So first of all, we will mark it as visited. We will put it in the call stack. Now this portion of the code is for exploring this current node, that is S. After the exploration is done, we remove the node S from the call stack. And if the cycle was found anywhere, we will be returning true within this for loop. In case a cycle was not found, we will just return false at the end. So let's look at the code. So S is marked as visited. We put it in the call stack. Now we explore every neighbor of S. Let's call it U. If u has not been visited and the cyclic function returns true when we start exploring from u, then we return true for the current call. Otherwise, suppose it was visited. If it was visited or if the cycle was not there, then we will come into this condition. This condition says if the current neighbor is already in the call stack. So if the node that you are exploring is already in the call stack, then also you have to return true. So what are the two conditions in which you are returning true? First one is that the neighbor u has not been visited yet. So we are exploring, we go on to explore u by calling the same function. And if this returns true, we will return true. The second condition is maybe the node u is already visited. If it is visited, is it in the call stack? If it is in the call stack, then we return true. So we will explore every neighbor of u, and if we did not get any true condition from here, we will come outside the for loop, pop off s from the call stack. So we mark s as false. That means s is no longer in the call stack, and we return false. Now let's look at the undirected. Now let's look for the undirected graph. This is the given undirected graph, and we can clearly see that there is a cycle here. This is the visited array to keep track of the nodes that have been visited. Let's start from node 0. Since I'm starting from node 0, I have to mark it as visited. From 0, I have only one option, that is to go to 1. So I go to 1, mark 1 as visited. I'll also keep track of the parent of 1, that is the node from which call has been made to this node. So for this p is equal to 0. From 1, I have three options, 0, 2, 3. Since 0 is the node which has made a call to 1, first of all, it is already visited. Secondly, this is the node that has made call to 1, so I'll not go back to it. I'll go to 2. For 2, parent is 1, mark 2 as visited. From 2, there is only one option to go, and that is back to its parent, so it will not be counted. There is no one else to go. So the call for this node ends here, and we go back to the node from this where this call was made. From 1, I have already explored one option. The next option is to go to 3. So I'll go to 3. For it, the parent is 1. Mark 3 as visited. From 3, there are 3 ways to go. To 1, to 4, and to 5. 1 is the parent, so I won't go there. I'll go to 4. Mark 4 as visited. And for 4, the parent is 3. From 4, I have two options. 1 is the parent, so I'm not going to go there. I'll go to 5. Mark 5 as visited. For this, the parent is 4. From 5, I have two options again. 1 is the parent, so I'm not going to go there. Next one is 3. But 3 has already been visited. So if from a node, I come to a node which has already been visited and which is not the parent for this node, then there is a cycle. So we notice a difference here. For the case of an undirected graph, we don't need to maintain an in the call stack array like we were doing for a directed graph. Why is it so? For understanding that, let's look at these two cycles. This one is for a directed graph, this one is for an undirected graph. If I start exploring here from 0, I put 0 in the call stack. I go to 1, put 1 in the call stack, and I'm also marking them visited. From 1, I go to 2, mark 2 as visited, put 2 in the call stack. Now from 2, there is nowhere to go because this edge is directed from 0 to 2. So I'll pop off 2, then I'll go to 1. From 1, there is nowhere to go. I pop it off and then I go back to 0. From 0, we can go to 2. Now 2 was already visited, but it was not in the call stack. Since it was not in the call stack, I will not say that we have found a cycle here. But on the other hand, for this graph, I start going from 0, mark it as visited. From 0, I go to 1, mark it as visited. From 1 to 2, mark 2 as visited. And from 2 to 0, since 0 was already visited and 0 was not the parent for 2, then there is a cycle. We can see here that in this case we did not require a call stack because there are no directions on the arrows. But here these two structures are similar. The only difference is that this one does not have any directions for the edges and this one has directions, and we needed call stack here because of that. Let's look at the pseudo code for finding cycle in the undirected graph. The detailed code will be given in the description. So suppose S is the node that we are exploring, P is its parent. First thing we do is we mark S as visited. Then we start exploring all the neighbors of S, say U, if U is not visited. Then we will call the same function on U with parent as S and see if it returns true. If this is true, then we will return true. Else if U was visited and U is not the parent. So this is that case. I'm saying from S I have come to U. U is already visited and U is not the parent of S. Then also return true. So I had reached S from some other vertex, say vertex V. So V was the parent for S, and from S I am reaching a node U which is already visited and is not the parent for S. Then we have to return true. So this way we will be exploring all the neighbors for the node S, and if we don't return true anywhere here, the loop will end and we will return a false. Now I hope I was of help and I hope you understood this. If you have any doubts, please ask in the comment section. Bye bye.